Good day everyone. In this video we shall discuss realization of current source inverters. I will start with realization of single phase current source inverters first. For current source inverters, input side we have a stiff current source. Current through the current source is more or less constant. We are going to have this kind of current source input side, and output side we have AC load. So for which voltage across that can take either polarity and current through that can flow in either direction, right? So now in order to realize this single phase current source inverter, we require two single pole double throw switches as shown in the figure. So this is the first SPDT and second SPDT. Okay. Now poles must be connected to current sources, the input current source, because current through current source must be continuous, which is possible if and only if it is connected to pole. Okay. Now so there are two single pole double throw switches. Now let us see what would be the voltage and current across load as well as across SPDC for various switching positions. First let me take this switching position. So this switching position, that is pole 1 is connected to throw 1 and pole 2 is connected to throw 2. Okay, so for this connection, what should be the direction of current flowing through the load? So that should be this way, that is this way. So this is the direction of the current, right? So current direction, let me take different color here. Yeah, so this is the current direction, right? So whenever you want the current, output current to flow through the load in this direction, we should connect pole to T1, pole 1 to T1 and pole 2, P2 to T2. Okay, and what about voltage across load? Load voltage can take either polarity. And what about the remaining throws? So now for this particular switching portion, between pole 1 and T1 dash, the voltage should block either with this polarity or this polarity. So based on the load voltage between pole 1 and throw 1 dash can take either polarity. Okay. Similarly, between pole 2 and throw 2 dash, voltage across load can take either polarity based on the load condition. But what should be the current between pole 1 and T1? That should be this way only. Similarly, between pole T2 and throw 2, so current must take this direction. So that is corresponding to the position 1, that is switching position 1, switching state 1. Now for next switching state, that is this switching state. So where pole is taken from this position and connected to throw 1 dash, and similarly pole 2 is connected to throw 2 dash. Now for this particular connection, so current through the load would take reverse direction when compared to the previous switching state, right? And what should be the voltage between pole 1 and T1? So that can take either polarity. Between P2 and T2 also, that can take either polarity, and that depends on the load voltage. In fact, that is same as the load voltage. Okay. So now if you see, so we require two SPDTs, single pole double throw switches. So you can see there are so this is switch 1 and this is switch 2. So two single pole double throw switches. And what should be the requirement on switches? The switches must be in such a way that they should block the voltage with the either polarity between any pole and throw, and they should carry current in only one direction as shown in the figure, between any pole and throw. So the requirement of switch is they should block voltage with either polarity and should carry current in only one direction. So we require unidirectional and bipolar voltage blocking capable switches. So how can we, and how many such kind of switches are required? In order to realize this single pole double throw switch, between P and T1 you require one unidirectional bipolar switch, Between P and T2 also you require one more. Okay, you require one more unidirectional and bipolar switch. Similarly, between P2 and T2 and P2 and T2 dash. So again, you are going to have two unidirectional and bipolar switches. So total you require 4 unidirectional and bipolar switches. Okay. So how can we realize that? So we know for inverters usually in order to realize the input stiff DC current source, we use a DC voltage source in series with a large inductance which can make the input current stiff. So this is the circuit topology usually we follow to realize the single phase current source inverter for input side. Okay, input source can be realized using a DC voltage source in series with large inductance which can make the input current stiff. And coming to the load, of course load can be any kind of thing, that depends on the application. And coming to the switches, you require 4 bipolar and unidirectional switches. And we know thyristor is a bipolar and unidirectional switch. It can block voltage with either polarity, but it will carry current in only one direction. So we can use SCRs. In fact, SCRs are so popular in order to realize current source inverters. Okay, current source inverters uses the thyristors usually or SCRs. Or you can use this kind of switches also. Instead of thyristor, you can use this kind of combination of switches to realize the unidirectional and bipolar switches. So now you can see in case if IGBT or any control transistor so is connected in series with a diode as shown in the figure, so it can block voltage with either polarity but however it carry current in only one direction. So by adding a diode in series, what are we doing? So we are making it bipolar switch. Okay. So this way also you can realize the current source inverter. Okay. So the important observations: thyristors are natural option to realize the switches which are bipolar and unidirectional, or else we can use MOSFETs or IGBT with series diode as the bipolar and unidirectional switches. And current through load decided by the switching state. So now for switching state 1, current would be in this direction as shown in the figure, and for switching state 2, current is going to be opposite to the direction shown in the figure. And voltage across the load determined by the load, type of the load and load value. Okay. Now this is about the realization of single phase current source inverter. Now coming to the 3-phase current source inverter. So similar way we can realize. Okay, we can realize the output side we have 3-phase load, but input side we have a DC source. In fact, a stiff DC current source. So which can be realized using a DC voltage source in series with large inductance. Okay. Now if you see the load is connected this way. So 3-phase load is connected this way. So which is usually balanced kind of load. Now we require a single pole triple throw switch. Okay, and we require 2 single pole triple throw switches in order to realize 3-phase current source inverter. Okay, so whenever so in order by varying the switching position, you can have the current flowing through different phases. Okay, so here current through load can be controlled by the switching state, by controlling the switching state. However, voltage across load depends on the current through it as well as load value. Okay, so now requirement on switch. So switch action between each pole and throw should block voltage with either polarity is so similar to that of the single phase current source inverter, but should carry current in only one direction. So again, so between any pole and throw you require a bipolar and unidirectional switch. Okay, so that can be achieved using thyristors. So between a pole and throw, so see, this is a pole, right, and this is throw 1, 2 and 3. So between pole and each throw, we must have a bipolar and unidirectional switch. So that is what we are doing here. We are using a SCR, is a unidirectional and bipolar switch. And similarly, so this is a second pole and so corresponding throws. So here also you should have a unidirectional and bipolar switches. Thyristors are natural options to realize the switches. So you require 6 bipolar and unidirectional switches. So you require 6 thyristors. And of course, so instead of thyristors, we can use MOSFETs or IGBTs in series with diodes also. Okay. And current through load is decided by the switching state, switching condition. However, voltage across the load depends on the type of the load and load value and current through it. So here once again, so we should ensure that switching scheme must be adapted to produce 3-phase balanced voltages or currents across the load. Okay, so 3-phase balanced voltages across the load or current through the loads. So now let us summarize what we discussed about current source inverter realization. So with respect to single phase current source inverter, we have seen that we require 2 SPDT switches with poles connected to source terminals and throws connected to load are required. And in order to realize those 2 SPDTs, we require 4 bipolar unidirectional switches. Similarly, for 3-phase current source inverter case, so we require 2 single pole triple throw switches with poles connected to source terminals and throws connected to load are required. And in order to realize those 2 single pole triple throw switches, we require 6 bipolar and unidirectional switches. And in order to realize bipolar and unidirectional switches, so thyristors are natural options. However, we can also use MOSFETs or IGBTs in series with diodes, is unidirectional and bipolar switches. Okay, so this is it. So in next lecture, in next video, we shall discuss the operation and analysis of single phase bridge inverter under various load conditions. Thank you.